Hello and welcome to Vision Academy. My name is Hanmant Ladwa and in this video we are going to write a C program to convert a given binary into decimal. Let us write a preprocessor directives hash include in angular brace we'll write standard input output dot h header file hash include in angular brace console input output dot h header file void main function curly open brace, and now in a declaration section we are going to declare all the variables of type integer. I'll take n and then dec, that is decimal number, and it is set to 0 value. I'll take one more variable called base and it is equated to 1, and r represent it is a remainder. Now I'm going to write CLR SCR function which is used to clear the screen. Now we'll ask the user to enter the binary number using printf function. In double quotation mark I'll write enter the binary number. So here colon and the double quotation mark and put semicolon. Now we are going to receive the input from the user through keyboard using scanf function. In double quotation mark I'll write format specifier %d that represent integer, put comma, and we'll take this n, that is ampersand of n, and put semicolon. Now we'll use the looping structure while n is greater than 0. If it is greater than 0, if this condition is true, then the control enters into the body of while loop. Here I'm going to write remainder r is equal to entered number n modulo division by 10. So this always returns us the remainder, and put semicolon. I'll write DEC decimal number is equal to decimal number plus remainder into base, and put semicolon. Now I'll write n is equal to n integer division by 10. So this always returns the quotient after the division. Now I'm going to write base is equal to base into 2. Now let us close this while loop. If this condition is true, then all these 4 statements will get executed. Now I'm going to write printf statement, and inside the printf statement I'm going to write the decimal number. The decimal number is equal to %d and the double quotation mark, and then put comma. I'll write here decimal number, and then I'll write get ch function and curly closing brace. So now let us take an example. Here I'm going to write output. When we compile and run this program, it will ask the user to enter the binary number. So here I'm going to write enter the binary number. For example, I'm going to enter 101. So this is stored in variable n. So n is greater than 0. Condition is true. Once the condition is true, all these 4 set of statements will get executed. So first remainder r is equal to n is what? N is 101, that is 101. Here we'll write 101 modulo division by 10. So this gives me 10 ones are 10 tens are 100, 1 is remainder. Modular division always returns us remainder, that is 1. 1 is stored in r. Now the second statement is decimal number is equal to decimal. For the first time it is set to 0. So we'll write 0 plus r is what? Remainder 1 into base. So base is equated with value 1. So here 1 into 1 is 1. 1 plus 0 is 1. So 1 is stored in decimal. Next statement, n is equal to, n is what? 101 integer division by 10. So this always gives us quotient. So 10 ones are 10 tens are. So 10 is the quotient here. Next we'll write base is equal to, what is base value here? Base value is, here it is 1. So 1 into 2. So this gives us 2 only. So 2 is stored in base. So first iteration is over. Again control transfers to while loop, and it is going to check the value of n. Now n value is what? 1 0. So this is the first iteration. Again, here it is not equal to 0, or you can say it is greater than 0. Hence, it is true. Once again, all these four set of statements will get executed. So I'm going to write them here. R is equal to, now n value is what? N value is 1, 0, modular division by 10. So this gives us the remainder. So 10 ones are 10 ones are 10, and the remainder is what? 0. Now we'll write DEC, decimal number, is equal to, now you can see the decimal number is 1. After this, the first iteration, I'll write 1 plus remainder is what? 0 into base. Base was 2. So now it is multiplied with 2. 0 into 2 is 0. 0 plus 1 gives us 1. So 1 is stored in decimal. Now I'll write the next statement. N is equal to, N is what? 10. That is 10 divided by 10. So this gives us the quotient. 10 ones are 10 ones are. So quotient here it is 1. Now the next statement is base is equal to, what is the value of base? Base is 2. So 2 into 2. So this gives me 4. So 4 is stored in base. Now what is the value of n? Again control transfers to while loop by checking this condition. So n is 1. 1 is greater than 0. Condition is once again true. Once again these four statements will get executed. So this completes the second iteration. Next we'll go for this particular statement. Here I'm going to write R is equal to, now n value is 1, modular division by 10. Here numerator is less than denominator. The basic rule of mathematics says that when the numerator is less than denominator, then the numerator acts as a remainder. So here 1 is the remainder. Similarly, we'll write the next statement, decimal number is equal to, here decimal number was what? It is 1 plus remainder is 1 into base. What is the base value? 4. So 4 into 1 is 4. 4 plus 1 is 5. So 5 is stored in decimal. Now n is equal to, n is what? N is 1 and then 10. So here the quotient becomes 0. Because whenever I say remainder is 1, then the quotient becomes 0. Here n value is set to 0. Next, base is equal to, base into 2. What is the value of base? 4. 4 into 2 is equal to, so this gives us 8. Now let us see one more time. So this is the third iteration. Again control transfers back to while and it is going to check the value of n. Here what is the value of n? N is set to 0. So 0 is greater than 0? No. Condition fails. Once the condition fails, control comes out of this looping structure and it is going to print the next statement. So printf the decimal number. So what it is going to print? Here I am going to write the decimal number is equal to percentage d decimal number. So here what is stored in decimal number? 5. So 5 is stored in this variable. So it is going to print 5. So here 101. So this 101 represent the decimal number 5. So let us execute this program. For that I will take you to my laptop screen. Here I have already written this program in Turbo C++ integrated development environment to save your time. Now it's time to compile this program by pressing Alt F9. Here it is showing success, means there is no syntax error, and I'm going to press enter now. And now it's time to execute the program by pressing Ctrl F9. Here it is asking the user to enter the binary number. I'm going to enter 101 and then I'm going to press enter. Here it is showing the decimal number is equal to 5. So similarly, once again I'm going to run this program by pressing Ctrl F9 and I'm going to enter a different number, that is 1010. It should give me the decimal number 10. So I'm going to press enter now. Here you can see the decimal number is equal to 10. I hope you understood. If so, please write down in the comment box as understood. Thank you.